some special probability. Over the last few lecture sections, we looked at probability distribution, what a random process is, and how to find a distribution to a random process, okay? Today, we want to look at special probability distributions. And three key distributions we will be looking at in class are the Bernoulli, the binomial, the normal distribution. We want to know what they are. We want to look at their properties and how they can be used in real life scenario. Now, what is a Bernoulli trial? A Bernoulli trial, like you can see in the coin, okay? Any experiment that generates a head or a tail. In a probability context, we will say a success or a failure, okay? Good. Or a yes or a no. Or yes, success, failure, yes, no, true or false, okay? All those kinds of events are what are Bernoulli trial. So for example, if you write an example, one person writes an example, okay, the outcome could be pass or fail. So once you have just two possible outcomes, then such an experiment, okay, is a Bernoulli trial. Now, what we need to understand about this experiment or this kind of trial is it occurs only one. So if we talk about a toss of a coin, we are just tossing one coin, okay? Just one toss of a coin. So it's either going to be a success or a failure, okay? So we say that the probability distribution of such a process is going to be, we'll write the probability of X, okay, is going to be either a success or what? It's either a success, okay, or a failure. And a success, we write it as X is equal to 1, meaning that is what we are expecting, the success, okay? Whilst we write a failure as X is equal to what? 0, okay? But the probability that we have a success is defined as small p. And the probability of a failure is defined as 1 minus what? P, okay? And sometimes we write it as Q. So that gives us the probability distribution for a Bernoulli trial or a Bernoulli experiment. Now, the expectation for a Bernoulli trial or an experiment is giving us the same probability of what? Success, okay? Whilst the variance of the process, which is sigma squared, is giving us the probability of success times the probability of failure. Okay, now extending this concept. Good. So we have an example here. It says, if X is the number of heads that show up in the toss of 3 coins, find the expectation and the variance. Okay, good. No, I think we've skipped. We are the Bernoulli trial in the binomial trial. Sorry. Let's look at the binomial process. So now, when a binomial distribution is a Bernoulli trial which has been repeated a number of times, okay? So, which means that there is a success or a failure. And then again, the experiment has been repeated more than once. We said in the Bernoulli, we toss only one coin. But if we toss more than one coin, then the Bernoulli experiment becomes what? A Bernoulli trial becomes what? A binomial trial. Okay, good. So the key point here is a binomial distribution is a Bernoulli experiment or distribution which has been repeated. Okay, so the key features of such an experiment is we have the outcomes of every trial is either a success or a failure, and then there is a fixed probability of success, which is P, and the experiment is repeated. Okay, and for such an experiment, the probability distribution, the P of X, okay, X is going to be given as N combination K, okay, as you see on the board, right, times the probability, okay, of success raised to the power K, times the probability of failure, which is 1 minus P, okay, raised to the power N minus what? Minus K. So that gives us what? The probability, okay, of observing K successes in a given what? Trial. Now, on your calculator, okay, look on your calculators. I forgot to mention, but in today's class, you need your calculators, but use your scientific calculators, and you need your statistical tables as well, close to you, because we'll be making reference to that a lot. So make sure you have your calculators at this moment, because we are going to need it in the next example. Okay, now expected value, expectation of a binomial experiment is given by N times P, meaning the number N is the number of repetitions, okay, or the number of trials. Then the variance is N times the P times the Q, okay, good. You know, in the Bernoulli trial, we said the expectation is P, and the binomial is a repeated Bernoulli. So it means that the number of times we repeat it, we multiply that number of times, which is the N, with the probability, and that gives us expectation, whilst the variance is going to be the number of times P times Q. So that gives us the variance for the binomial distribution. So you take note of these formulas. We are going to use that to run some examples. Good. Okay. So okay. So let's look at this. It says if X is the number of heads that show up in the toss of 3 coins, okay, find the expectation and variance. Good. Now we know that in a coin, the probability of observing a head when we toss one coin, okay, is either going to be a head or a tail, right? Either a head or a tail. So there are 2 possibilities. Okay, so our sample space, it has 2 elements, but the probability of a head will be 1 out of the 2. Okay, good, it's half. The probability of a success is going to be what? Half. So we have 1 over 2 as the probability of the success. Then we also know from this experiment that the experiment has been repeated. Okay, so we have N of 3. Okay, a repeated trial or experiment. So N of 3. So if we are looking for the probability, okay, or let's start with the expectation. If we are looking for the expectation, per the formula, we are told that the expectation of a binomial trial is N times P, okay? Whilst the variance for a binomial trial is N times P times Q. You saw it earlier. The variance, like we said, is N times P times Q is 1 minus P. Q is the probability of failure, okay? So 1 minus what? P. Okay, so if you look for the expectation, that will be N is 3. We know that is the number of trials, that's the repetitions. So we have 3 times the probability of success will be what? Will be half. So we have half there, and that will give us 3 times half is 1.5. Then for variance, we have 3 times half, okay, times another half, because 1 minus half will be half. Good. And when we multiply that, that should give us 3/4 for the variance. Okay, so that is how we find the expectation and the variance for a binomial random experiment. Now, what if I asked in this same experiment, in the toss of 3 coins? I believe we did an experiment on the toss of 3 coins in class. Okay, so we want to find the probability of observing at least, let's say, 1 head. Okay, the probability of observing, yes, let's say probability of observing 1 head, 1 head for now. So if we are interested in having a head, which is just 1, k equals to what? 1 head. Okay, then the probability distribution, we said P of x equal to k. So k in this case is 1, will be equal to n combination k, right? So our n is 3, and then our k is 1. Okay, times the probability of success, that's observing a head, which is half, right? Raised to the power what? Raised to the power 1, times the probability of a failure, which is half, raised to the power 3 minus 1. Okay, from the previous formula, right? So for those of you who are wondering, maybe you just came in, let me just write the formula out for you. So this will be the formula for the probability we saw earlier, that P of x equal to k, okay, is equal to 3, n combination k. I'm just writing out the formula. So n combination k times P raised to the power k, okay, times 1 minus P raised to the power n minus k. Okay, so we are using this formula, okay, to find the probability. So that is what we have here. N is 3, k is 1, P is half. 1 minus P will be 1 minus half. So that will also be half. Since k is 1, we put the 1 here. Then we have 3 minus n is 3. K is also what? 1. Okay. So now it's left to us to do the calculation on our calculators. Now somebody will be wondering, how do we get the 3 combination 1? On your calculator, look for a symbol n combination x. Some of you will have it n combination x. I think it's on the division sign. If you find it, just give me a yes on the chart. So on the division sign, you find this notation here. If you found it, give me a yes on the charts, and then let me give you the next instruction. Okay. So Mensa says he has found it. Let me get some more responses. So look for n combination x. Okay, fine. Kwame says n combination. That's okay. That's okay. So if we are looking for n combination r, how do we compute it? What do you do is, okay, that's okay. So what we are going to do is first type 3. Okay, 3. Okay, and then press shift. Shift is at the top corner of your calculator. So first type 3, press shift. Then you go to that button there where you found the n combination r. Okay, so 3 shifts, then you press N combination R, then you press your 1. Okay, so I'm repeating it again. First type 3 shifts N combination R and press 1. So when you do that, it will look something like this on your calculator. 3 combination 1. Okay, and when you find that, that should give you an answer of what? Of 3. If you're able to do that, give me a yes on the chat. Very good. Bernard says he's obtained it. Okay, that's good. That's good. That's good. Well done. Well done. You are doing well. Okay. So, yeah, very good. You've all gotten it. So that is 3 times. Now you are going to handle this calculation. 3 times 1 over 2 raised to the power 1 is 1 over 2, right? And then 1 over 2, this is 3 minus 1, so it will be 2, right? So this will be 1 over 2 raised to the power what? 2, okay? So compute this for me and give me the final answer. So compute and give me the final answer. So compute everything for me and let me have the final answer. Three over 8. That's good. That's good. Yeah, you're all doing very well. Please make sure you are doing the calculation if you are not. Okay, it's very important. You know, some topics are like that. If you don't calculate, it becomes difficult for you to understand. So make sure you are calculating. I can't be at your place to supervise you, but make sure you are doing the calculation at your end. Very important. Good. So our answer is 3 over 8. Now, let me draw this table again, the probability distribution, and see if it rings a bell in your mind. 0, 1, 2, 3, and then P of X 1 over 8, 3 over 8, 3 over 8, and 1 over 8. Now, this is the 3 over 8 we have just found. When X is equal to 1, probability is what? 3 over 8. Does this distribution ring a bell in your mind? Do you remember this table? If you do, just
yes, sir.
Good. So you see, because that process was a binomial process, when we use the probability distribution of a binomial process, we will get exactly the probabilities we obtained in the earlier class. I think we did this last 3 weeks. Okay? Because that process was a binomial process, if you use the special distribution function to examine the properties of the process, you are going to get what? The exact probability. So you realize that when we find the probability of X equals to 1, where we are observing just one head, the probability is 3 over 8, okay? So at home, you can try X equals to 2. When you try X equals to 2, it will be, I think you should try it for B. So when you try X equals to 2, that is going to give us, let me clear this first. That will give us, now it will be probability of X being equal to 2 is equal to 3 combination 2. Okay, so you do that with your calculator. 3 combination 2 times 1 over 2 raised to the power what? 2. Okay, then we have half raised to the power, okay, 3 minus 2, which will be 1. Okay, so do that calculation and let's see whether you are still going to get 3 over 8. We are expected to get 3 over 8. So do the calculation and see if you get a 3 over 8. And give me a minute, I'll join you soon. Okay. So our answer from what we are getting is 0.24576. So that gives us the probability that a machine will work, okay, for 4 out of 6 days when we are given a probability of 0.8 for it to work. Okay, any question at this point? If you have any question, you can ask. Any question, raise up your hand first. Yes. So, Isaac.
Please take it again. Can you go over again of the question for me, please?
Okay, so please listen attentively. We've been given the probability that the machine will break down, okay, as 0.2, breaking down. If the thing does not break down, then it's working, okay? So if the probability of breaking down is 0.2, then the probability of working will be what? 1 minus 0.2, which is 0.8. But in the question, we're told that if the production firm works from Monday to Saturday, find the probability that the machine will work. So our success here, what we are interested in is working, not breaking down. Okay, that is why your P here is now 0.8, because that's the probability of working. Then this one will be the 1 minus P, which is the probability of breaking down. Okay, 0.2, right? Using the probability distribution. So once you do the calculation from your calculator, 6 combination 4, okay, times P raised to the power K times 1 minus P raised to the power N minus K, we should get 0.2476. Okay, good. If there is any other question you can ask before I move on.
Yeah, I'm a little bit clear.
Good.
Thank you.
Good. Yeah, any other question, class, before I move on to the next slide? Okay, so if not, let's move on. I'll skip this as okay. Yeah, so the next distribution we want to look at will be the normal distribution. Okay, and this distribution is so important for us as scientists because naturally anything that takes place over and over becomes what? Normal. Okay, even in daily sense, when something is abnormal and it keeps repeating and repeating and repeating, it becomes a norm and becomes normal. So we say it is normal now, right? So in the same way, mathematically, we can prove that any process, whether be a binomial process, a Poisson process, any process at all, once it takes place over and over, can become or will become what? A normal distributed variable. Good. Now let's see what it means to be a normal distribution. The process or the probability distribution is given as you can see here. So the PDF is giving us 1 over 2 times the power negative half times x minus mu over sigma all squared. So that gives us the probability distribution function, okay, for the normal distribution. Now, what we need to understand about normal distribution is the normal distribution is for continuous random variables. Okay, good. So any continuous random variable, okay, with parameters mean of mu and a standard deviation of sigma. Just a minute. Okay. Yes, okay. So the normal distribution has parameters of mean mu and the standard deviation sigma. No problem.